Greetings everyone. Today we're going to explore writing linear inequalities. We do have a notes sheet for this. It definitely would be worth making sure you have a copy or printing one off, as it is a bunch of graphs that we're going to write inequalities for. Let's take a quick moment to go over some problems for review. You don't need to write these down, but I just want to refresh your memory. In our last unit that was all about graphing lines, we had to isolate y first, right? We could also use intercepts, but the most common practice was let's get y by itself. And once we have y by itself, notice this is a 1/3 x, make note of that, then we were able to graph, right? So we said, oh, I start at 3, that's my y-intercept, rise 1, run 3. And my rule was always 5 or fill. And then we connected them and we drew arrows. And then we added on the element at the end of the last unit of what if I make this an inequality, right? What if it's a less than or equal to symbol? Well, then we had to decide, this is going to be a solid line. Remember, solid or dashed. Solid because it has a bar under it. And then we shaded. And we explored the idea of a test point, meaning if I plug in 0 for both variables, in this case, is 0 less than 9? Yes, that's good. So we shaded the 0, 0 side. But even easier, you guys, once it says y is less than, does less than sound like above or below would go with it? Below. Less than goes with the idea of shading below the y-intercept, meaning I shade below the line. And so today our goal is the reverse. We're going to say, given this graph, I want you to write a linear inequality. Let's look at a quick review as well of what happens when I don't know the y-intercept. We've been struggling with this a little bit because some of you still want to make an assumption about the value of that y-intercept, and I can't. And nor do you need to. It's a quick fix. Let's just use point slope form, right? If I use point slope form, let's identify the pieces. Well, I can still count my slope. That's pretty easy, right? 2 over 3, rise over run. And I could use either dot. I see the dot -2, 2, or I see the dot 1, 4. Doesn't matter to me which one you use. And we can write point slope form, meaning y minus 2 equals 2/3 x plus 2. So we shouldn't have to figure anything out when given the graph. We should identify the pieces and write the line. And again, today the extra element we're going to add in is what if it's shaded. Well, I shaded below the line. Below the line is less than. See how that works out? All right, so let's take a look with our specific examples. We want to start off thinking of it as a regular line, but we want to write it as an inequality to meet the needs of that shading and the set of solutions. So first of all, I notice this is a horizontal line. It slices the y at 1, slices the y at 1. So we're used to saying y equals, right? But I have an inequality here. I shaded above the line. Above is greater than. It's a dashed line, which means it does not need a line underneath it. Let's try another one. On this one, I'm going to identify the parts first. Let's start with the slope. If I take a look, I don't know if that's a dot. That doesn't look like a dot there. So let's find a for sure dot. Like this one here looks for sure. And this one here looks for sure. And 0, 0 looks for sure. Don't make guesses, right? Pick dots that are for sure. So this would be down 1, 2, 3, 4. So -4. Right 1, 2, 3, 4, 5. My slope is -4/5. So be careful with counting. I also know that I cross the y-axis at 0. I also know I could use the point 5, -4, or I could use the point -5, 4. So you have lots of options. No matter what, I have the same slope, but I'm going to show you 3 different inequalities. -4/5 is my slope no matter what. If I take a look, I shaded above the line. Above. Above means greater than. So instead of equals, I put greater than. Now, if I choose the y-intercept, then it would say y is greater than -4 x plus 0, but I don't need to write the plus 0. That's an SIF form. But let's say I want to use point slope form. Then I would have y plus 4 and x minus 5. Well, let's say I wanted to use this point. Then I'd have y minus 4 and x plus 5. If you need help with writing PSF, please see that video. But we're just doing the same thing again and again and again. The only new thing today is the red inequality symbol. All right, let's go again. First of all, I just want to acknowledge where my dots are on this one. I want to see if there's a repeating pattern. So if I draw on my paper, that'll help me count my slope. My slope is down 2, right 1, down 2, right 1. And we want to simplify that. I have a y-intercept of 5, or I could use any of these dots. It really doesn't matter to me which way you choose to write it. Let's say I stick to y equals mx plus b on this one. That means my slope is -2, my beginning is +5, and I shaded above the line. If you're not sure, go to that y-intercept. Look at, I shaded above the y-intercept. Above is greater than. It's a solid line, so we want a or equals to line. Let's go again. I see a dot here, probably there, right? So if I count my slope, it looks like my slope is rise 4, run 1, which would just be 4, right? We want to simplify that. My beginning is also 4. I have a y-intercept of 4. I also have some points I could use. I could use -1, 0. I could use -2, -4. I'm going to show all 3 on this one, but you only write down one of them, all right? First of all, my slope is 4. No matter what, every inequality has a 4. I'm going to set up an SIF and 2 PSF. And let's talk about our inequality symbol. If I go to the beginning, the y-intercept, it's shaded below. Below means less than. It's dashed, so we just use less than. Now, if I choose to use SIF, it'd be a +4. If I choose this point, it would be +1 and 0, so I don't need to write it. If I chose this point, it'd be +2, +4. All of those are acceptable linear inequalities given the graph. A couple more left. Let's take a look at this one. I'm going to write to the inequality for this graph. I'm first going to identify the pieces so I don't mess any of that up. It looks like each one of these is a dot. Oh man, that means there could be like 12, let's see, yeah, 12 different inequalities that you write for me, but let's stick to just one. First of all, my slope is down 1, right 1, which means -1. My beginning, my y-intercept, crosses at +1. I'm going to stick with that for my inequality. Y equals mx plus b. More specifically, let's take care of our inequality symbol. We shaded above the y-axis, above the y-intercept, above the line. If it's above, it's greater than. The line is solid, so we also need an or equals to. Let's go again. Our last one that we have on our notes looks like it has these points, and if you're not sure, make sure you can repeat the pattern. As long as you can repeat the pattern, you can see your rise 1, run 3, rise 1, run 3. I cross the y-axis at positive 3. I have the points 3, 4, 6, 5, negative 3, 2, and negative 6, 1. I could write 5 different inequalities for this. I'm going to write 2. So the first one I'm going to choose is SIF, slope-intercept form. So that would look like y 1/3 x plus 3. And my inequality, let's see, we shaded above. Above means greater than. For the next one, I'm going to use the first point I wrote. We'd have y minus 4 and 1/3 x minus 3. My inequality symbol is the same no matter what because it's the same line. Here's just an extra one. You don't need to jot this down. I'm going to go quicker through this one. I see that I'm rising 3, running 1. Rise 3, run 1. I cross the y-axis at negative 5. Oof, that's really bad writing. Let me try that again. Rise 3, run 1. I'm crossing at negative 5, and I'm shaded below with a solid line. Right? So some of these, once you get in the habit, they should be this quick. Alrighty, that's our explanation for for writing linear inequalities from a graph. Make sure that you check out Google Classroom. What's the task today? What do we need to accomplish? What do we need to finish? Let me know if you have questions or concerns. And until next time, have a good one.